Hi guys, Dr. Lando. Going to do a video on dehydration synthesis versus a hydrolysis reaction. So both of these reactions are for dealing with monomers and polymers. Monomers being the subunit of biomolecules and polymers being the larger biomolecule made up of monomers. So some examples of monomers are, if you're talking about carbohydrates, I'm just going to use the letter C for carbohydrates. Change this real quick. And so for carbohydrates, glucose is an example. For lipids, you might use fatty acids, Fa, as your example of monomers. For proteins, amino acids, AA. And for nucleic acids, we would use nucleotides. So these are the subunits that we will hook together to make the polymers. So what would the polymer of glucose be? Well, there's a few of them that we learned. An example would be glycogen. An example of a polymer of lipids, you could say a triglyceride, since we're going to hook 3 fatty acids to a backbone of glycerol. Proteins, amino acids are the monomer. If you put a bunch of amino acids together, you're going to get a peptide. Okay. And then nucleic acids, if you hook a bunch of nucleotides together, you're going to get a nucleic acid. So DNA, deoxyribonucleic acid, or RNA, ribonucleic acid. Okay, so now what we want to look at is kind of a quick look at the chemical process that hooks these monomers together, and then the process that breaks down the polymer into the monomer. Okay, so go to the next page here. All right, so we're going to start with dehydration. In dehydration, we are going to connect monomers together to make a polymer. So this guy right here and this guy right here are my 2 monomers. Now we know with all the biomolecules that we drew in class and saw in class that they all have these hydroxyl groups sticking off of them, and they all have hydrogen groups sticking off of them. Okay? So those are important because they are what is going to take part in the reaction. So how does this happen? Well, there are enzymes that are going to do this for us. And in class, I used a description and said that these enzymes were like hands that would come up and grab onto these groups pull them off basically, and when they pulled them off, they pulled off an OH, which is a hydroxyl, and a hydrogen. They would join them together to make H2O, which is water. Not the best water droplet, that's water. Okay? So we pulled water out. So imagine those 2 functional groups being pulled off, and when they do, we've got basically an open spot and an open spot. So what happens? That molecule joins together, okay, and makes a bond. Sometimes that bond has a special name. Like, for example, in proteins, we call that a peptide bond. Okay? All right, so good. All right, so now we are going to look at hydrolysis. Okay. Okay, now that we've done dehydration synthesis, we can move on and talk about hydrolysis. So in dehydration, where we removed water, we dehydrated it. In hydrolysis, we're going to add water. And a matter of fact, if you were to translate what hydrolysis really means, you'd say it is breaking with water. Because lysis means to rupture or burst. And of course, hydro means water. So breaking with water. So we're going to break that bond with water. Well, now the hands are going to come back in, but this time they're bringing water, right? That's a bad hand there. So they're going to take water and push it. Make that a little bigger so I can draw in there. They're going to push water into that bond. So we're going to push H2O into that bond. And when that happens, it's going to break the bond between the two monomers, and H2O is going to be split, and we will get an OH attached to this monomer, and a H attached to this one, a hydroxyl over here, and a hydrogen group over here. And there's your water, H2O. Okay. And so there you are. The hydrolysis has been done. It was broken with water and split those two apart. So now you go from having two monomers that were hooked together to two separate monomers. We went from a polymer to two monomers. All right. If you have any questions, please feel free to email me. Thanks.